Hello students, in our previous session, we studied why oceans matter, the five major oceans of the world, the relief of the ocean floor, coral reefs, and the concept of salinity. Today, we'll move ahead with some very dynamic topics: waves, currents, El Nino and La Nina, tides, and ocean-linked transport routes. Waves are the oscillatory movements of seawater, mainly generated by winds. You can imagine them as the rise and fall of the sea surface. Waves don't transport water, they mainly transfer energy. When they reach shallow areas, the lower part slows due to friction with the seabed, and the upper part topples forward. That's how breakers form on the shore. These waves are very important agents of erosion. Over time, they carve bays, capes, cliffs, and sea caves. Tsunami is a special kind of wave. It is generated by an earthquake, volcanic eruption, or landslide under the sea. In deep oceans, tsunamis are low in height but travel very fast. When they approach coasts, they rise into giant destructive walls of water. A well-known example is the 2004 Indian Ocean tsunami, which caused massive damage in Southeast Asia and India.
Sir, may I ask a question?
Yes, please go ahead.
Why are tsunamis more destructive near the coast than in the open ocean?
Good question. In deep oceans, the energy spreads across great depth, so waves are low. Near the coast, shallow depth forces the energy upward, creating tall destructive waves. Now, let's turn to ocean currents. These are continuous, directed movements of seawater caused by forces such as wind, Earth's rotation, temperature and salinity differences, and even tides. A simple rule to remember: in the northern hemisphere, currents circulate clockwise. In the southern hemisphere, they circulate anti-clockwise. Types of currents: warm currents flow from the equator towards the poles. They raise temperatures of coastal regions. Cold currents flow from the poles towards the equator. They cool down coasts and sometimes bring fog. Where warm and cold currents meet, we find some of the richest fishing grounds. For example, Newfoundland in the Atlantic is famous because the warm Gulf Stream meets the cold Labrador Current there. Similarly, the coasts of Japan benefit from the meeting of the warm Kuroshio and cold Oyashio currents. North Pacific Ocean, warm, North Equatorial Current, Kuroshio, Alaska Current cold, Oyashio, California Current. South Pacific Ocean, warm, South Equatorial Current, East Australian Current cold, Humboldt or Peru Current, West Wind Drift. North Atlantic Ocean, warm, Gulf Stream, Florida Current, Antilles Current cold, Labrador Current, Canary Current, Greenland Current special. The Gulf Stream continues as the North Atlantic Drift, which warms Western Europe. South Atlantic Ocean, warm, Brazil Current, South Equatorial Current cold, Benguela Current, Falkland Current. Indian Ocean, strongly influenced by the monsoon winds. Warm, Agulhas Current, Mozambique Current cold, West Wind Drift, seasonal Somali Current seasonal drifts, Southwest Monsoon Drift and Northeast Monsoon Drift along India's coast. These are opposite phases of the El Nino Southern Oscillation, ENSO. El Nino means the little boy in Spanish. It refers to abnormal warming of central and eastern Pacific waters. Global impact: droughts in India and Australia, floods in South America, disrupted monsoons. La Nina means the little girl. It refers to abnormal cooling of Pacific waters. Global impact: stronger monsoons in India, more cyclones in the Pacific, heavy rains in Southeast Asia. Tides are the regular rise and fall of sea level caused by the gravitational pull of the moon and the sun. The moon has greater effect because it is closer to Earth. The basic cycle: about 12 hours 25 minutes between two high tides. Types of tides: spring tide, Highest tides when the sun, moon, and earth are in line, full moon and new moon. Neap tide, lowest tides when sun and moon are at right angles, quarter moons. Perigee tides, stronger tides when the moon is closest to earth. Apogee tides, weaker tides when the moon is farthest. Special case tidal bore when incoming tides form a wave moving upriver, like in the Hooghly River in India. Uses of tides, they aid navigation, port management, and tidal energy production. Finally, oceans are not only natural highways but also connected through canals and long railways. Important canals and seaways, Suez Canal, Mediterranean Sea left and right arrow Red Sea, shortcut from Europe to Asia. Panama Canal, Atlantic left and right arrow Pacific, crucial for American trade. Kiel Canal, North Sea left and right arrow Baltic Sea. St. Lawrence Seaway, Atlantic left and right arrow Great Lakes. Transcontinental land routes, Trans-Siberian Railway, Moscow to Vladivostok, longest in the world. Canadian Pacific Railway, Halifax to Vancouver. Orient Express, Paris to Istanbul. Pan American Highway links North, Central, and South America. Stuart Highway, Australia, Darwin to Port Augusta. So students, today we explored waves, currents, the El Niño La Nina cycle, tides, and transport routes. With this, we complete the important oceanography chapter. Keep revising the diagrams and maps because location-based questions are very common. Jai Hind.